Okay, good morning to everyone. In the yesterday's class, we were solving about some of the problems. Um, in that, this is one more problem. Of course, in the previous class, we solved three problems. One problem is related to the separate system, and one more problem it is related to the combined system. And the third one is related to only the calculation of runoff coefficient. So now we'll go ahead with one more very important problem. Um, uh, Maybe this is the toughest problem you can see in your examination. Maybe they won't ask, but some of the competitive exams, um, like in your UPSC examinations, those who are preparing for uh, Indian Engineering Service examinations. Slightly, the problems of like this, it will be there, and slightly they will make some variations. I'll tell you what kind of variations they will make. The same problem it has been appeared in 3 or 4 times in a ES examination. Slight difference they have made it. I'll tell you what they have did it. Of course, the problems are very easy in the competitive examinations, but why they will what they will do is that they will change the units. For example, we have empirical formula is there that we already discussed. That is Q is equal to uh, CIA. Q is equal to CIA. That uh, formula is there. But normally, what they will do is that in that we already know that that is Q is equal to C I A divided by 360. So now in this you can see that C is the runoff coefficient, and I is intensity of rainfall. And remember that I should be substituted in mm per hour. This is what he will do is that instead of that I, what he will substitute, he will give you in terms of centimeter per minute. Then when you substitute it, you will go wrong. So this kind of problem is there. The similar kind of problem, even he has not changed some of the data also. Whatever in the table you are observing, the type of cover, coefficient of runoff, and the percentage, it will be the same. It has appeared same, but only they have changed here in this 30. He has changed it to 30 centimeter per minute, and here he has changed it as uh, instead of 200 LPCD, he has taken 135 LPCD. Maybe I'll show you that exactly. I'll share you that maybe in the next class. And here also he has changed it. Here he has given 350 persons per hectare, but there he has given 350 persons per meter square. Then you should be able to convert the hectares to meter squares to hectares. We already know that how to convert from hectare to meter square, that is multiplied by 100 into 100. So now this kind of things he will do, but the same problem it will be there. Similar kind, whatever we saw is very important as the examination point of view. Then if you say, we'll start with the problem is the catchment area is 300 hectares. The surface cover of the catchment can be classified in the given below. So you can see that here roofs is there, pavements and yards is there, lawns, gardens is there, roads is there, uh, open ground is there, and single family dwellings are there. So, and how much percentage all these areas are covering that he has given? 15% area the roofs are covering, another 15% area pavements and yards is covering, 25% lawns and gardens is covering, roads is covering 20%, open ground it is covering 15%, single family dwellings it is covering 10%. You can observe the from top to the bottom, you can observe that the value of runoff coefficient, that is for roofs it is 0.9, means there is very less infiltration is there, means roofs are almost, it is a leak proof, whatever the water it will be there, it will be come out. Pavements and the yards, if you say it 0.8%, means slightly infiltration will be more. Then lawns and gardens, again here it will be more, because more vegetations will be there. According to that, you have more infiltration will be there. Then roads, of course, if some type of roads if will be there, if it is not covered with like cement concrete roads, then normally slightly infiltration will be there. Then open grounds, it will be like what almost all the whatever the water it will be there, it will go and it will infiltrate. Next, what he has asked is that calculate the runoff coefficient, means in this you can see that you have to calculate the C value. Then the quantity of storm water runoff you have to calculate it, means how much storm water is coming out from this area. And he has given the intensity of rainfall 30 millimeter per hour, that is nothing but I. For rain with duration equal to the time of concentration, means whatever it is there, whatever the 30 minutes is there, how much the rainfall is happening, means for example 30 minutes the rainfall is happening, that 30 minutes will be the time of concentration. We already know that the time of concentration, that is a T, C is equal to TE plus TE, means it will be time of, it is time of flow, it is F. This is TE, means it will be time of entry plus time of flow. Your time of concentration is nothing but it is the TC is equal to TE plus TF. That we already defined it in the previous class, what is time of entry and what is time of flow. Next, if the population density of the area is 350 persons per hectares, means he has not directly given the population. What you have to do is that you have to calculate the how much population is there. You can see that at the top you can see that 300 hectares of area is given. Then if you need population, if you need the population, then that P is equal to 300 into 350, you have to make it. Then how much you'll get? That will be your population. So means he has given 350 persons per hectare, then it should be multiplied by hectares. Then next it will be, he has given the rate of supply is 200 LPCD. It is nothing but the rate of demand. We can call this is as the rate of demand. Then what he has asked is that here you have to calculate for separate system, partially separate system, and you have to design it for combined system. So in the previous problem, we only calculated separate and combined system, but we have not calculated it for partially separate system. So this is a complete one problem. If you understand this, it will be like what all the systems, whatever we are designing it, that we are going to do it completely. So then we already know that the combined system is nothing but combined is equal to, it is separate okay, we'll go ahead with the next. Okay, the combined is equal to tar motor plus sewage flow. So it is nothing but it is sewage flow. So if you want to calculate the storm water, so you have to use the formula called Q is equal to CIA divided by 360, where C is the coefficient of runoff, I is the intensity of rainfall, and A is the area in hectares. I should be substituted in mm per hour, and C is having not unit. Then sewage flow can be calculated by multiplying the population and the rate of demand, followed by the how much sewage it is going to come out from the using rate of demand. This can be calculated with the population into rate into how much percentage of sewage is going to come out. So now first we will calculate the runoff coefficient, that is C. What he has asked with it, that first we have to calculate C, then we have to use the formula called A1 C1 plus A2 C2 till AN Tn divided by A1 plus A2 up to Tn. The similar thing we have used it here. We can see that here it is the 1.5, that is 15%. For if you see the previous table, in the first table you can see that roofs. So roofs is having, it is coefficient of runoff is 90 and it is 15. So 15 divided by 100. Here it is 15 divided by 100. That will give you 0.15. So that they have taken here for the first case. You can see here that is 15 divided by 100 is nothing but 0.15, multiply by that is coefficient, that is 0.9. Similarly, he has calculated for all the basins, all type of basins. Then finally he got the average C as this much, because we require C here. The same you have to substitute in this formula. Next, calculate the quantity of stormwater. So in this you can say that Q is equal to C, that is C, how much, that is 0.4, that we already calculated. Then this is 30 mm per hour as given. Then it is 300 hectares divided by 360. Then whatever you are getting here, it should be in meter cube per second. So then we got the stormwater flow as 11 meter cube per second. And remember that this second, always you write it as small s, not SEC. Make sure that it is small s only. And remember that in this formula, A should be substituted in hectares, I should be substituted in mm per hour, and C should be, it is having no unit. Then here we have calculated the stormwater flow. It is nothing but stormwater flow. Stormwater flow. Next, calculate the sewage flow. So when you are calculating the sewage flow, start with first population. Population he has not given. Population is equal to 300 hectares he has given. Hectares multiply by 300 persons per hectares. So once you do this, they will get the value of the population. Similarly, he has did here. You can see here, this is the population calculation. Then next thing is, it is the rate. This is the rate, and this much we have to assume it as 0.8, means 80% of the water demand is coming out as the sewage flow. So then if you calculate this, they will get, this is nothing but this one. So 80% of the water demand is coming out as the sewage. Then we got the value as, that is Q of sewage equal to 0.194 meter cube per second. Again, you have to do some conversions here. Normally, you will get this is how, if I split this, you make this as Q, or we'll do it separately. Okay. Now, you can see that Q of sewage, if you split it, it will be 300 into 350. If I split it, the whole, whatever the calculation, that is 200 liters per day. Means capita is there, already we multiply it. Then it is 0.88. If you want to convert that into meter cube per second, what you have to do is that divided by 1000 into 24 into 60 into 60. So then you will get it as, calculate it, you will get it 194. If you ask me why I am multiplying 1000 here, means it is a conversion of liter to meter cube. We know that 1 meter cube is equal to 1000 liters. Then day it is there, 24 hour, 60 minutes and 60 seconds. So now we got the Q of sewage. Then assume the peak factor as 2. I already said that if you refer the CPHU manual, it will be 2 to 3 is there. That I already explained it. You have to take suitable, either you can take 2, in between 2 to 3, any value you can take. Now you can take only 2. Then if you take the design, it will be 0.194 into 2, that is 0.389 meter cube per second. So we got the Q of sewage. Now come back to we determined the separate system where we can call it as only the stormwater, then partially separate system. So in this case, now we have to design the partially separate system, where you can see that here one assumptions normally will make it when you are designing the partially separate system. Sometimes in the problem he is mentioned that the partially separate systems, which are the things are going to contribute, or which are the areas are going to contribute the separate systems. But here he has not mentioned anything. But when you are designing separate, normally you have to take roofs and pavements are normally added to the separate systems. Why? Because the maximum runoff, if you take any city area, the maximum runoff water drains or the pipes, roofs water drains are directly connected to the storm water drains, as well as the road surfaces. Means they are designed, whatever the separate systems, partially separate systems are designed mainly for the roofs as well as the pavement courtyards, or we can call it as roads, paved roads. So then it will be added to the sanitary sewages, whatever it will be added, you have to assume this, whatever the roofs and paved poured yards, it will be there, it will be added to the sanitary sewers. Normally these connections will be there for sanitary sewers. So then how you have to do this? First you have to separate, we calculate the C value for this, because previously C, that is the average of all the areas, but now here we have to C of roofs plus paved, that we have to consider it. So when you are doing that, if you go back to the C value of the roof, it is 0.9, then C value of the paved, that is 0.8. Then he has given the area, it will be 15%. Here also he has given area 50%. If you go back and if you see, see here, you can see that it is, the roof says 15% and pavement is 15%. Now, but area is, total area is 300 hectares. So then 15% of this 300 hectares is 45. 15% of this 300 hectares is 45 hectares. If you calculate it, you will get it. So 15% of 300 hectares means for 100% 15 is there. For 300 how much? In that way you have to do the calculation. For 100 15% is there, 15. For 300 how much? X. If you cross multiply it, you will get it. So then if you calculate it, so that is why he has written 0.90 into 45 and 0.80 into 45 divided by, it is nothing but A1 plus A2. You have to use the same formula, that is C is equal to A1 C1 plus A2 C2 divided by A1 plus A2. This is what the C of your roof plus pave. So if you calculate it, you will get, it is 0.85. Then how much discharge is coming out in this? If you calculate, use again the formula same, that is Q is equal to C I A divided by 360, that is equal to C is 0.85, that we already calculated, then 30 mm per hour, it is 30 mm per hour, .85 into, it is 30 mm per hour multiplied by 90 hectares divided by, whole divided by, it is 360. So then it will be 6.375 directly meter cube per second. I already said that Q Q, it is always, it is in meter cube per second. So then, if you calculate it, so add, that is sanitary sewer we already calculated, that is how much? 6.375. Then that is store motor is 0.389. So then total you will get it as 6.764. Then normally we know that combined is we already know store motor plus sewage flow. In this case, you can see that the discharge and store motor we already calculated how much from all 300 hectares. If you see this value, it is the coming from total 300 hectares. But this one is the total partially including your sewage. This one. Then the remaining amount, how much? The store motor, with that it will be this minus this. So means this my 6.375, it is going to contributed from only two areas, that is roofs and the paved, because it is the highest area, that is 15%. And there, why we are getting to the major portion? If you analyze this problem, total we are getting 11 meter cube per second from the whole area, but almost 60% it is contributing, means 6.375, means there the infiltration is very less. If you see the infiltration coefficient of the roofs and paved, for roofs it is C of roof is equal to 0.9 and C of pave it is 0.8. Mean highest rainfall will come in this areas. Of course the total area is very less, 45, of course it is 1/3 it is there. Still if you see the coefficient of runoff and coefficient of paved area, it will be more. That is why you are getting the 6.375, it is more. This is how you have to analyze the overall problem. Okay. Maybe if any problems or if you have any doubts in this problem, you can ask.